This new video will introduce you to the way that we have to work with wavelength, frequency, and speed when it comes to the fundamental wave equation. Recall that the wave equation says that velocity is equal to the wavelength times the frequency of the wave. So let's get started with this simulation again. We have a certain string and we have the source of the wave at the left end of the string, and we can go and adjust the amplitude, the frequency. We don't have any damping factor over here, forget it for now. And we can start, let's try to click on it. You can see that we have a transverse wave produced by this oscillating source at the left. And now the point of interest, let's stop it for a while, is that we need to see how the wavelength is connected to the frequency and the speed. First of all, let's start with the basics. The speed has to do with the properties of the matter. In simple words, when we have a string, maybe we know the material it is made of. Okay, we also know the tension. Can you see here? The tension can be set low, medium, or high. So when we say the properties of the medium, we mean the tension of the string, the material it's made of, its thickness, etc. So once we have defined which material we are talking about, the speed remains constant. So since we have to work with the equation speed equals frequency times lambda, it is obvious that since the speed remains constant, lambda and f are inversely proportional quantities. Let's try to see it. Running the simulation, let's try to increase the frequency. Can you see that increasing the frequency has a result of decreasing the wavelength? If we pause it for a while, you can see that the distance between two consecutive crests or troughs of this transverse wave is decreasing. And if we go again and now decrease the frequency, we can see that the wavelength is now increasing. And in this way, we have confirmed that wavelength and frequency, you can see it again, increasing the frequency decreases the wavelength and vice versa. So let's summarize again. Let's repeat it. Wavelength and frequency are inversely proportional quantities, but under the condition that speed remains constant. Just in case that speed is changing, is varying, then things are completely different. Okay, let's try to see it in another way now. Let's say that we keep the frequency constant. Let's put it around 1.5 hertz. And now, let's restart it. We go here and change the tension. As I said before, the tension is one of the properties having to do with the medium of propagation. So in this way, changing the tension changes the speed of propagation. Recalling the same formula again, V equals lambda times F. Since now we have another factor that remains constant, okay, let's say that we keep the frequency constant, then the speed and the wavelength must be directly proportional. Let's try it. We keep the frequency close to 1.49 hertz. The wave goes like this. And now let's say that we increase the tension. Since we increase the tension, you can see that the wavelength is increased. Watch it again. Decreasing the tension decreases the wavelength. Increasing the tension increases the wavelength. It is clear. Why? Because increasing the tension increases the speed. Don't forget, frequency remains constant. Got it? So, since frequency remains constant, we have speed being directly proportional to the speed. And speed increases because I have increased the tension. Let's stop it again. Summarizing again. The point of interest is that this formula, V equals lambda times F, describes the relationship between these three fundamental properties, fundamental quantities of a wave. But there is a but here. We must be very careful when it comes to the results we get by using this formula. If something is supposed to be inversely proportional or directly proportional to another quantity, we must take into account which property remains constant and why. You have to check it again. You can go to PhET Colorado simulation. It's simple to find it. Okay, maybe I can send you the link. You can see it up there, and you can practice just the way I showed you. Thank you so much once more.